Welcome to Mrs. Law's class. In this video, we're going to take a look at the parabola, both the graph, the equation, and an application. So a parabola is a graph that's created by slicing a cone parallel to the side or the generator of the cone. So in this picture of the cone, the parabola would be created if we slice the cone right there. Now, there are two equations for the parabola depending on the direction of the parabola's opening. And you've learned one of them from grade 11, and that's where the parabola opens up or down. So we know that when the parabola opens up or down, we have the standard form to be y equals a bracket x minus h all squared plus k. Now, in grade 11, you probably used P and Q instead of H and K. But it doesn't really matter what the variables are, as long as you know that the H and the K, they stand for the vertex. Now, when the A is positive, the parabola opens up, and when A is negative, the parabola opens down. So notice that the A value is the number that is in front of the x minus h squared. Now, the last thing that you need to know about parabolas is the equation of the axis of symmetry. And we know that the axis of symmetry is where x is equal to h, because that h value tells us the translation horizontally. So let's draw a quick little graph so we can see what it looks like. So there's my axis, x and y. And let's just draw a rough parabola that opens up. So here, down on the bottom, that is called the vertex. And that is H and K. And then down through the center, we have the axis of symmetry. So we know that the left side is equal to the right side. And that's equal to h, like I said before, because it has a horizontal translation of h. All right, so how do we get a parabola that opens left or right? Well, let's take a look at the graph first. So I'm just going to draw a rough x and y axis. And I'm going to draw a parabola that opens up to the right. And we'll draw in our axis of symmetry. Now, the vertex is right here, and we still use the variables h and k, and we have the axis of symmetry, which I'll point over here, and we can see that this time the axis of symmetry has moved down, and the axis of symmetry is dependent on the y value now. So y is equal to k. Now, if you recall from transformations, a sideways parabola is actually an inverse of a parabola that is facing up or down. So if we have our equation, let's draw this down, y equals ax minus h all squared plus k. To find the inverse, we swap x and y. So now we're going to have x is equal to a bracket y minus. Now I'm also going to swap my h and k so that we can keep it consistent that the h value is associated with the x and the k value is associated with the y. So our vertex here is still h and k, but you have to remember that the h value is now the number on the outside, away from the squared. When a is positive, the parabola now opens to the right. When a is negative, the parabola now opens to the left. And the equation of axis of symmetry, as we can see from our picture, is y is equal to k. Let's take a look at a couple of examples so you can see what a parabola looks like exactly. So here we have the first one, where it's y equals 3x plus 4 all squared. And we can see that we don't have a number on the outside, so let's add a 0 to help us remember that our vertex will now be -4 and then 0. The axis of symmetry, because there is a movement or a translation of -4 to the right, our axis of symmetry is x equals to -4. So domain is all real numbers, because remember that parabolas open on and on to left and right. And then our range is y is greater or equal to 0, because the graph has not moved down, but it has stayed on the x-axis because our k value is 0. So we can graph this by transformations, or we can draw a table of values. Now, if you're using transformations, you're going to use the base graph y equals x squared. So comparing these two, we can see that the plus 4 means that our graph is going to move 4 to the left, and the 3 means that we're going to expand vertically in the y direction. So I'm going to use a table of values. We're going to start with -4 and 0 as our vertex. And then we're going to pick two numbers on either side, equidistant from -4. And when we plug them in, we're going to get 12, 3, and then we have 0 already, 3, and 12. So remember, when you're graphing this, you can use the symmetry to help you know that once you have one point, you should be able to graph the other point on the other side of the parabola because it is symmetrical. So make sure you draw a nice kind of U shape on the bottom. Don't make it too pointy. And there's our parabola. All right, now let's take a look at a parabola that opens sideways. So here, like I've said before, the h and the k, we start with the number on the outside. So that would be the 4. And then our k value would be the 3 because that's associated with our y. Now our axis of symmetry, because the graph opens sideways, that's going to be associated with our y value. And our vertex is 3, so y is equal to 3. Now the graph opens up, all the way up and all the way down, so our domain is no longer all real numbers, but our range is all real numbers. And what's happened to our domain is it is going to be x less than or equal to +4. Now the reason that it's less than is because of the negative here for the half means that the graph opens to the left. And then our vertex is 4, 3, and so x is associated with the number 4. We're going to use a table of values again because I want to show you how to graph parabolas with a fraction. So we place our vertex in our table, and now instead of picking x values, we're going to choose y values because it's easier for us to find y values and then solve for x. Now we also have this half, so we're going to skip count by 2's so that when we plug these numbers into the equation, I will get integers for x values. And you can try this. So once we plug these numbers in, we'll get -4, 2, and we already have the 4, and then 2, and then -4. So plotting these points on our graph, you get these 5 points here, and then you connect them in a nice smooth curve to get a sideways parabola that opens up to our left. Let me just draw this one again. So we're actually going through the points. All right, so the next thing we're going to take a look at is how to write the equation of a parabola, given some information. So in order to write the equation of a parabola, we know that we need the vertex and the a value. We need the a value because it indicates the direction and the width of the parabola. Now, usually the a value is what we need to look for because we're given the vertex and a point. And we also have the direction of opening or the axis of symmetry. And we need that information so that we know that whether the graph opens up or down or left or right. So let's take a look at an example. So here we have a vertex of -2, -3, and it passes through the point -5, 1 with a horizontal axis symmetry. So let's draw a graph first so that it helps us to visualize all of our information. And we'll plot our point so we know that this -2, -3, that's our vertex. -5, 1 is a point. Now, seeing this, the graph could open up or it could open left since this is the vertex. However, it tells us that it's a horizontal axis of symmetry, which means that we have an axis here, and therefore the graph must open to the left. All right, so we're going to plug all our information into x equals a bracket y minus k all squared plus h, because it's sideways, our h and k are -2 and -3, and then our x and y value are -5 and 1. So we're going to plug these numbers into our equation. And we're going to solve for a. So add the 2, and then we have 16 here. So a is equal to -3 over 16. And then we're going to write our equation to be x equals -3 over 16, and then y plus 3 all squared minus 2.